Hi everyone, let's see how to find the mean, median, and mode from a frequency table for discrete data. In this example, we're told that the results obtained at the IB physics exam last year are summarized in the following table. And we need to do three things. First of all, we need to calculate the mean result that was obtained. Secondly, we need to find the median result. And finally, we need to state the mode. Now, before I start, I should say, as I work through this example, you may find at times that I'm going to go into quite a bit of detail. So if ever you feel the need to skip ahead from one section to the next, I've added timestamps or chapters to this video for you to skip ahead or move backwards if needs be. That being said, now we can get started. The first thing we need to do is calculate the mean. And to do so, we can use the following formula. The mean, which we write as x with a little bar on top, is equal to the sum, which we write like so, of all the frequencies times their corresponding x values divided by the total number of values we have. And in fact, I'll go ahead and box that. There we go. Now, I know that this formula can look a little bit confusing. Don't worry though, this is going to be explained clearly. First of all, the f with the subscript I, or f sub I that we have here, refers to the different frequencies we have inside our frequency column. And in fact, I'll write a little f sub I at the top of it. Like so, f sub I. Each of these frequencies is multiplying x sub I, and x sub I in this example refers to all the different grades that we have. And so in a similar way, I'll write x sub I at the top here. There we go. The n that we have on the denominator refers to the total number of values we have. And to find it, all we have to do is calculate the sum of all of the frequencies we have inside our table. And when doing so, we typically write the total at the bottom of the column, in this box here. And so calculating 2 plus 1 plus 6 plus 10 plus 12 plus 9 plus 5, you can go ahead and check, but I find that's equal to 45. So we now know that the n on the denominator here is equal to 45. Now, what this sum of f sub I times x sub I is telling us to do is to calculate the sum of each of the frequencies times its corresponding x value. In other words, on the numerator here, we need to calculate the sum of 2 times 1, and 1 times 2, and 6 times 3, and 10 times 4, and 12 times 5, and so on and so forth. And to do that in an organized way, what we typically do is add a column to our table. And in that column, we're going to write all the results of f sub I times x sub I. And I'll quickly extend the rows here. And now I complete these cells. So for the first one, we have 2 times 1. So that's 2. Next, I have 1 times 2, which again is 2. I then have 6 times 3, which is 18. 10 times 4, which is 40. 12 times 5, which is 60. 9 times 6, which is 54. And finally, 5 times 7, which is 35. Now I need to calculate the sum of all of these values. And I'll write the result at the bottom of the column again, so I make another red box, like so. Now, by all means check, but 2 plus 2 plus 18 plus 40 plus 60 plus 54 plus 35 is equal to 211. And 211 is exactly what goes on the numerator here. And so we can now state that the mean is equal to 211 over 45. And by all means check, but with my calculator and rounding to 3 significant figures, I find that the mean result is equal to 4.69. And that's rounding to 3 significant figures. Done. I move on to the second thing we need to do, and that was to find the median results. Now for that, what I like to do is add a cumulative frequency column to my table. So I'll do that now, just adding the rows here. And at the top of this, I'll write cumulative frequency. Now, to complete the cumulative frequency column, we look at the frequency column. And the first value of this column is the same as the first frequency we have. So that's 2. To find the next value, I add the next frequency to the 2 we just found. So that's 2 plus 1, which is 3. And I carry on this way. For the next value, I do 3 plus 6, which is 9. 9 plus 10, which is 19. 19 plus 12, which is 31. 31 plus 9, which is 40. And finally, 40 plus 5, which is 45. And a quick check you should always do, the last value in your cumulative frequency column should be equal to the sum of all the frequencies, which is the case here. Each of these cumulative frequency values tells us how many grades were less than or equal to the grade we see on the same row. For instance, the 9 we have here tells us that the first 9 grades were less than or equal to 3. Or the 3 we have here tells us that the first 3 grades were less than or equal to 2. But now, alongside the cumulative frequency values we have here, when looking for the median value, I like to add a little more to this. And that is, I like to indicate which values fall inside each of the rows of my table. Here's what I mean. I know that the first 2 grades fall within the first row, and so I write from the first value to the second. Consequently, the third value falls in the second row, and since there's only one value in this row, I'll write from the third to the third. The next row will have the fourth up to the 9th value, so I write my 9 here. Then the next row will go from the 10th to the 19th, then from the 20th to the 31st, from the 32nd to the 40th, and from the 41st to the 45th value in the last row. And I like doing this because now I can see that if I were to write all of the 45 grades in a long list in increasing order, then the first and the second grade would be a 1, the third grade would be a 2, the 4th to the 9th grades would be 3, and so on and so forth. And now that I've done that, I'm ready to find the median. For that, the first thing I need to do is to find the median's position. So I'll just write median's position. And there's a nice and convenient formula for that. And that is that the position is equal to n plus 1 over 2, where n is the total number of values we have. So in this case, that's 45. So the position becomes 45 plus 1 over 2. That's equal to 46 over 2, which is equal to 23. And careful, this 23 isn't the actual median, it simply tells us the position of the median. So we could say that the median is the 23rd value. Now, looking back at our cumulative frequency columns and the numbers that I wrote on the right-hand side here, I quickly see that the 20th to the 31st value fall inside this row here. Consequently, the 23rd value is somewhere there. And that tells us that the median is equal to 5. And I can go ahead and write that. I'll say median equals to 5. Done. Finally, the third thing we had to find was the mode. Now, to find the mode from a frequency table, all we have to do is look for the highest or largest frequency. And looking at our frequency column here, it doesn't take us long to see that the highest or largest frequency we have is 12. And consequently, the mode is 5. And so I can state that the mode is also equal to 5. Done. And I should say, the mode and the median won't always be equal. That just happens to be the case for this example. And there we go. We now know how to calculate the mean, the median, and the mode from a frequency table for discrete data. And that's it for this tutorial.